Alright, let's make this video, try to make it shorter than 5 minutes. We're trying to compare which cars have better mileage, US cars versus Japanese cars. There's a whole array here and a whole array here. These are miles per gallon. This is, I would say, we can almost tell that the miles per gallon for Japanese cars are going to be greater. Most of them look like they're larger than these. However, there might be some outliers. Plus, you will notice that this array of numbers has more units than this array of numbers. But let's just get to it. First, let's do a count. And this is going to be a little bit difficult because we have to select from A10 to, let's see, D43. If we can memorize that, A10 to D43 is going to make it a lot easier for later. A10, D43, so that when we do average, there you go, A10 colon D43. Ooh, perfect. And just to confirm, we can double click this and it will indeed highlight all these numbers, this array. Great. Standard deviation, STDEV, A10, D43. Perfect. And then 95% confidence interval. This just means we want to be very confident that whatever p-value we get, we would be at least a 95% certain that we are correct. And that if we are wrong, we're willing to live with that mistake or error because there's a less than 5% chance that we are wrong. So our formula is right here. And for confidence interval, you can always change it in case you are doing your IA in a future day or maybe next year. If you want to be very confident of your results, you can change this to 0.01. It would just mean that it would be maybe a little bit more difficult to get a p-value that is less than 0.05. Yeah. Anyway, so 0.05, and then we'll do standard deviation, and that is in K22. And then count, which is in K20, and that should do it. You cannot, in this case, you cannot click and drag these because, or maybe you can, nope, because it will select a different array unless you arrange these in 2 columns, like just take all these, put them underneath here, take all these in column C, put them underneath the other set of numbers, and then do the same with miles per gallon, and then set the 2 right next to each other. Yeah, but otherwise, this time you cannot just click and drag because it's such a large amount of numbers. Now let me pause the video and compute these numbers. So I decided I was just going to show you a shortcut. You can, for example, copy and paste that. Right, copy and paste. You can copy that, and then when you're going to do the average, just paste it. Bam. And then the other ones are pretty easy. So equal is, and then paste. Done. This will take. Oh, I think this one we can indeed click and drag because, because it's not computing anything from this array, rather it's computing or inserting numbers from these columns, and then our last number is the p-value, and here we'll do t-test. Perfect. And then here, this one is going to be a little bit different. I think I'm going to run out of time, a little bit over my 5 minutes. But you'll notice this is a 3 instead of a 2 or a 1, which we have used before. And the 3 is important because the 2 arrays, or the 2 samples of the 2 sample populations are not the same count. So that does affect the formula, that does affect how things are computed, because one array has more power than the other, and so that has to be adjusted in the formula. So let's just do as it says here, array number 1 I forgot what it was. I think it was A10 to D43. So A10 D43, perfect, comma, ooh, I still have that from my copy dashboard, and finally comma 2, comma 3. Again, the 3 is pretty important because, yes, because the arrays have different counts. And finally, we get a 0. This is what it means. Well, first, there's no such thing as p-value of 0. You know, there's always a chance that you can be wrong. There's always a chance that you can be wrong, because there is no way anybody could collect all the cars of all the Japanese cars and all the US cars and then put them in a formula. It's just impossible. These again are representing samples of a population, so we are assuming that these samples are representative of a much larger population. Therefore, a p-value of 0 is technically impossible, but Google Sheets cannot compute anything that is below 0.000001, something like that. So what this 0 represents is simply a p-value of something like 0.000001. So we are very, very confident that these two averages are different. But again, this is what our p-value of 0 stands for. It's not technically 0, it's just such a small number that Google Sheets interprets it as 0. Thank you, goodbye, and I will see you in the next video. I forgot to say, Pichun! Alright.